All right, we're on our last chapter, which is circles. Now, hate to break the news to you, but normally we would have done a very cool activity for this where we make a circle out of candy and you label the entire thing. It's actually one of my favorite activities of the entire year. I will post a picture of one that I've done previously just so you can see what I'm talking about and get all of a visual for all of these things. Okay. So we're going to talk about a few things. There's a lot of vocab words here with a circle, but essentially a circle is just, actually, do it over here. There is a point that exists and an infinite number of points around it. And once you find all of the points equidistant from the center point, remember there's all points all in here, you get a circle. I also have shown off my circle drawing skills. I do draw a pretty mean circle freehand, but nevertheless, let's move on. So here is your circle. Every circle has to be named by its center. And I don't know why, but usually the center is called O. Okay, so this would be circle O. The central angle is an angle whose vertex comes from the center. So this would be your central angle. I'm going to write these real quick if you want to. No, I guess I'll just write them real quick. So vertex at center. Okay, once you make your central angle, you'll see that it kind of splits the circle up almost like a pizza. Okay, this right here is called a minor arc, and it's minor because it's less than half the circle, which is 180. So let's talk about the semicircle first. Okay, a full circle is 360 degrees, so a semicircle would be half of that, or 180. That makes sense because look, it's a straight line. Okay, also known as the diameter. Since this little angle right here is less than a semicircle, it is called a minor arc. So it's an arc that measures less than 180. And if that's what a minor arc is, guess what a major arc is? It measures more than 180. Okay. We're going to talk about probably tomorrow the length of an arc, and that's something different. The measure of an arc is how much it is bending, and you'll see this a lot if you've used a protractor. This is the measure of the arc, so it's like how much it's turning to get to the other ray of the angle. So the measure of the minor arc, you're going to write it like this: measure, and let's call this AB of AB. And since it's an arc, we put a little arc on top of it. Okay? It only has 2 letters because it's minor. If it has 3 letters, it's major. That's the easiest way to tell them apart. So let's say you had another point over here. It could be anywhere. But what's left over would be if you traveled from A to C to B and never went into that little spot right there. So ACB would be the measure of the major arc. Okay? Congruent circles are circles that have the same length, radius, or diameter. So if this was 4 and this is 4, those are congruent circles. And congruent arcs are just these parts of the circles that are the same. So radius equal and congruent arcs is, I don't know, equal arc length. Measure. Here we go. All right, so here we go. These are honestly very, very simple. You should really just like fly through this today. You should be done in like 10 minutes if I could ever stop talking. So here we go. The circle here, it has a minor arc, and you can tell it's minor because it's less than 180. The measure of this minor arc is 50. So the measure of the major arc is going to be the difference between 360 and the minor arc, which is 50. And so the measure of this major arc is 310. And we said before the measure of a semicircle is 180 degrees. Here we go. Find the measure of each arc of a circle. The first thing you want to do in all of these is look for a diameter. If you look for a diameter, you will easily be able to figure out what your other measurements are. Get a calculator here. So what is the measure of DE? Well, it's the central angle, so it's just 117. Now, what I like to do is trace this. So even, I mean, obviously you don't have notes in front of you, but if you want to just draw the circle when you're doing the worksheets or the quizzes, you can do that. So DFE, I'm going to trace traveling from D to F to E. You have to go in order. Well, that's just going to be everything except for 117. Which is 243. And then the measure of DEF. So traveling from D to E to F, that's half a circle, it's 180. Okay, arc addition postulate, very, very easy. We have done, this is now like the third addition postulate. All it's saying is that the measure of A, B, C can just be found by adding the measure of these two arcs. So if this was 20 and this was, I don't know, 180, I don't know, 2. Then you would add together 20 and 182, and you would say that the entire arc here is 202. Pretty simple, right? Here's a few quick practice problems. If you want to just pause it and do them, or you can just watch me do them real quick, but I'll be done after this. So find the measure of CFD. Again, trace from C to F. Whoops. To D. Okay, do not travel like inside the circle. So from C to F to D. Well, first thing, look for a diameter. A diameter is 180. So I can very easily find out that this is 45 because this has to make 180. Okay. I can also look for now this diameter. And that diameter is also 180, which means that the angle that's missing is 180 minus 45 minus 81. So this is 54. So the measure of CFD is going to be either 360 minus 54, or you could have just added up all of these numbers, which would also give you 306. Okay. The measure of angle SPQ. Now this one's a little bit different because you have the measures of the arcs already. So you can take these, and because they're going to a central angle, you can put all of these just right inside of here. Then I'm going to trace SPQ. SPQ. All right, so you have a few options. We know it's going to be at least 86. There are no diameters here, but I can take 360 minus 86, 154, and 60. And that tells me that there are 60 degrees here. Now, technically, each of these is 30 because they are congruent. You don't need to split them into 30 and 30 because you're going to just add it to 86 altogether. And 86 and 60 is 146. Next one, EFC. So E to F to C. Well, let's do this. This is already 180. And then if you look at this diameter, you can figure out what that is because that's 180 minus 126. So this is 54. And so then you could just say it's 180 and 54. $234. And then the last one, MIJ. MIJ, it's an angle, so I'm going to go inside of here. Since this is 55, this angle is 55, and so this would just be the supplement of 55, which is going to be 125. The other thing I should mention is that since we're doing circles, all of this is in degrees. Next year, you're going to do stuff that's not in degrees, but for our purposes, our circle will always be measured in degrees. So that's really it for today. I'm going to do a quick quizzes assignment that shouldn't really take you that long, and then I'll post another video tomorrow.